Lahu, it's too hot. Okay, now we'll see kind of a 3D analogy of vector calculus. So, what is a vector? Generally, when we draw something on board to describe something, it is 2D description of some mathematics. But it is always a kind of nice to be pragmatic when we discuss any terminology in mathematics, then better to visualize in 3D. So if you don't visualize it in 3D, or if you don't visualize it, just writing equation on paper and then solving it here and there, it won't take you kind of too long. We have come to a stage in calculus and vector, and we have long way to go. So it's not kind of it's easy. Things are everything is very easy when you understand step by step, and then you visualize it. So that is the idea. If I do summation, then I visualize it. If I do subtraction, then I visualize it. So if there is a vector, then I visualize it. Okay, like if there is a vector this, so if I say there is a vector called 2i plus 3j plus 4k. Okay, so there is a vector called 2i plus 3j plus 4k. This is the equation of a vector. So vector is nothing but it's an energy, so it's an energy which has a magnitude. So energy has a direction. So energy which has a magnitude. So certainly energy has a direction. So if I say 2i plus 3j plus 4k, then someone would say draw a point at 2i in the x-axis 2, y-axis 3, and z-axis height is z-axis, then 4. Whatever point comes in from origin, draw the line. That is the vector, true. So that is called position vector. Okay, so 2i plus 3j plus 4k, 2, 3, 4 is the point. From origin, you draw a line through the point. So that is the direction of the energy, 2i plus 3j plus 4k. And what is the magnitude? So that is 2 square plus 3 square plus 4 square square root. So that will come around 29. So 29 square root. So that is the power of the vector, power of the energy. And what is the direction? Direction is from the origin. But that is one thing. What we understand with this? Okay, now suppose this is x-axis, this is y-axis, and this is z-axis. There are three energy sources. One energy is traveling in x-axis and it has power of 2. One energy is traveling along y-axis and it has power of 3, magnitude of 3. One energy is traveling along z-axis, that is k, and it has power of 4. So along x-axis one energy is going, y-axis one energy is going, and from bottom one energy is going. Now at origin all three collides, all three becomes one. If that is the case, then there is only one energy that will move from origin. So from up till origin, three energy sources are coming together and they are meeting at origin. One in x direction, positive y direction, and z direction. Once they meet, then one has magnitude of 2, 3, and 4. Where they will go? They will go in a direction of 2i plus 3j plus 4. This is another way of looking at energy. Vector is energy which has a direction and has a magnitude. So if energy which has magnitude of 2, 3, and 4 and direction in x, y, z, if they are coming from a direction and they are meeting at origin and they sum up, then where they will go? They will go in a direction. So that is called sum up. If they sum up, if I sum up 2i plus 3j, 2i, 3j, and 4k, what it will become? 2i plus 3j plus 4k. Since all three are orthogonal to each other, they are at 90 degrees. They do not have any multicollinearity. They do not, they are, all three are independent to each other. So there is no summation. If I have two mango and I get four mango, two mango and I get four mango, then how much it is? Six mango. No one will say two mango plus four mango, two mango plus four mango. Two mangoes plus four mangoes equal to six mangoes. Now I have six mangoes. I have two mangoes and two oranges. How much it will be? Two oranges, two mangoes. Two oranges, two mangoes. Because both are different. Like that, I-axis, J-axis, and K-axis, they are orthogonal to each other. Even they took part in dimensionability, but they are orthogonal to each other. They don't carry any change. If one changes, then other would not change. They are independent to each other. They are not collinear. In that fashion, if three energy source coming from these three different directions, if they meet at origin, then we say 2i plus 3j plus 4k. All are different. So new vector will come, which is mixture, which is summation of three vectors, that is 2i plus 3j plus 4k. Okay. Now, if I have a energy source and okay, now how much I would feel? So x-axis, y-axis, and z-axis. Suppose this is the actually energy vector that we are seeing. How much energy we feel because of if wind is flowing in a direction, if wind is flowing in a direction 2i plus 3j plus 4k. How if I am standing at x-axis, how much wind I should feel? If wind is flowing, blowing or flowing in that direction, that then how much energy I should feel when I am standing on x-axis, y-axis or z-axis. If I want to calculate how much energy I should feel when I am standing on x-axis, then if this is the vector, then this vector's component I would see first on xy plane. Okay. So if this is root 29, this is the hypotenuse, then height is 4. Okay. So 4 is the height, and then the strength of the vector is root 29. If that is the case, then probably we will go for cos inverse. If we do cos inverse, sine inverse, we'll do sine inverse perpendicular by hypotenuse. Then we'll get the angle. What is the angle? It makes with the xy plane. Now, if I am at xy plane, then I know the hypotenuse now. Then I know the base is 2. Then what angle it makes? So, one angle from the vector to the xy plane, another is from xy plane to the x-axis. Both if I do cos theta. Okay, so if my vector is 2i plus 3j plus 4k, then if I do cos theta, with theta is the angle with xy plane, then I'll see what is the strength of the energy in xy plane. Now again from the xy plane, I do again new cos theta, then I would get the what is the strength. So cos theta 1 into cos theta 2. So root 29 into cos theta 1 into cos theta 2. If I do, then I'll get what is the source, what is the essence of energy that I would feel if I standing on the x-axis. It would come as 2. 2i plus 3j plus 4k. If that is the energy source, then its strength, the essence of someone would feel on x-axis is 2. Y-axis is 3, and z-axis someone can calculate how much is the theta it makes with the xy plane. So someone can solve it through matrix also. This is what is being done in 3D graphics. So just we keep seeing essence, and we finally land up in matrices. And we go with matrix multiplication, cos theta, sine theta, cos theta, and end up we see that what is the final essence we see in a particular coordinate. So this is analogy of vector. So vector is nothing but if that it is a kind of summation of uh, two, three vectors that is in different direction, and they sum up at the origin and in what final direction they move. So that is the vector. What is its essence in three coordinates? So if that is the vector, what is its angle it makes with the xy plane? So this cos theta is that much. Then again, how much it angle it makes with the x axis. So that cos theta again. So cos theta 1, cos theta 2, and that is the root 29. So that much would be the someone should feel energy in the x axis. Okay, so if someone understand this concept, so this is 3D. If someone understand the how summation makes a resultant vector and resultant vector's essence along a particular direction, boss, he cracks everything. He cracks calculus, he cracks vector. That's it. Same thing is being repeated because in future I'll talk about more about 3D gradient. We have talked about 2D gradient vector, and then kind of what is dz by du. So dz by du in xy plane, dz by du can be in 3D. So where we will have gradient vector in 3D. Earlier we had gradient vector in ij only. It will be ijk, and the u vector will be ijk, and then everything will be in 3D. Whatever it is, if I understand the direction of the vector, then I must understand how much energy, if energy is flowing in that direction, then how much someone would sense the energy if he is standing in a particular direction. Okay, if this is the energy source, okay, and this is another vector. So this wood stick is one energy source and my hand is one. How much energy I should feel because of this wood? The angle is theta, then whatever the strength we see in this vector, cos theta. Okay, if this angle is theta, then if it is 90 degree, okay, so from my both hand are at 90 degree, this hand and this hand at 90 degree, the stick and the bottom hand angle is theta, then how much energy I should feel in this direction because of the stick? Then stick strength cosine theta. Okay, that's it. So that's why I talked that this much big lecture I gave the dz, what is dz by du in the direction of u. Then you just need to understand the u's component, the u vector component in x axis, and then what is the component of dz by du. So whatever the model we have taken in 3D, how much it is in x axis. Okay, so if I know, so how much it varies. So if I have a sphere, then how much dz by dx, how much it varies along x-axis. And if I have a vector, how much it varies along u vector, how much u varies along x-axis, how much that z, that shape varies along x-axis. That's it. So if you understand the components behavior, like three components x, y, and z, and how much energy is felt along x-axis, y-axis, z-axis for each vector, you are done. That's it. Whatever future I am going to make in the calculus and vector, it is that much only, and not even that. There will be complex to complex mathematics in artificial intelligence, where we have a class and uh, uh, class have set of attributes. I mean set of features, and one set of feature value. So if it has 20 features, then there are 20 different components x, y, z, alpha, gamma. Means so many components you can understand. Three only we can think in 3D graphics, but untouchable. They are not dependent upon each other. Hopefully, then in machine learning or artificial intelligence, a class has 20 components. Okay, then each set of 20 component value is each set of a vector. If 20 features are there and 20 feature has value, then it is a point in 20 dimension from zero origin to that point. If I draw a line, that is a vector. Or there are 20 different vectors, they are meeting an origin and they are summing to a single vector. That is a single value combination of those features, and that leads to a class. If in a particular way if they combine, so if that set are samples, so Each vector is a sample, nothing more than that. If I have 20 samples with 20 vectors, if 20 vectors are cohesive, they are similar, they belong to a one class, that's it. So if we understand the component related features, what is the component of energy in that direction? Means if I take 2D, then in XY plane, if energy is flowing in a direction, if I am standing on X axis, how much energy I should feel? If I am standing on Y axis, then how much energy I should feel? That's it. Now, suppose there is a magnetic field. Okay. So there is a, I believe it was here only. Okay. So there is a magnetic field. I mean, this is a motor. Okay. It can be seen, I believe. Okay. So this is a motor. Okay. So motor had a stator. We can see this round is magnet, and then we can see coils in the motor. Okay. So there are red color coil, and around this coil we can see magnet all around. So there white color round is magnet, and inside that there are coils. Okay. So round is magnet, all around round is magnet. So they have a magnetic field. So it's a radial magnetic field. So this is a magnet, round magnet. Then north pole to south pole, they there is a magnetic field. Now, and there is in between there is a coil. We can see. So coil, the way the winding has been done, it is orthogonal. Okay, so if this is a stator, stator means magnet, and there is another magnet like this, then magnetic field is flowing from this direction to this direction. If there is a wire that is flowing, this is magnet, this is magnet, this is north pole, this is south pole. So magnetic field is going in this direction. Now there is a wire that is from bottom to up, it is going. So current is going like this. So if current is going, current is nothing but it's an electromagnetic field. So in a magnetic field, one electromagnetic field comes in and its direction is orthogonal. If one is in x-axis and one is in y-axis, then there will be a force. Means it's a nature, right? Means if I am sitting in a room and if someone comes in, then there will be either repulsive or attraction. Okay, so if two energy source, if they come near to each other, I will either they will repel each other or they will attract each other. Okay, so if there is a magnetic field like this and there is a wire, and in the wire I am flowing another end, so there is energy, one kind of energy from this direction to this direction, another kind of energy that is flowing in a wire. Okay, so this is magnetic field and there is a wire. So wire, so if magnetic field and electromagnetic inside the wire, if they are orthogonal to each other, then consider this is xy plane. If it is xy plane, so there will be a force that will be generated in along the z axis. Okay, if current is in x axis and magnetic field is in y axis, L cross B. So what is the strength of the current? How long the wire is? Li. How long the wire is? How much is the current? Multiplied by how much is the magnetic field. But it should be 90 degree to each other. So this is how we are talking about vector. If this is the current and this is the magnetic field, if this is the magnetic field, inside that there is a current in this direction, then it will generate force on the current on the electric wire in z axis. If this is magnetic field and this is the current also, this is the magnetic field and this is the current also, but it expect current to be at 90 degree, then only it will generate nice force. But magnetic field is in this direction, current also in direction, then how much force it would generate? What is the component of the current along the axis on which it is expected? Zero. Because if current is flowing in y direction, then strength of the current along x axis is zero. If current is flowing at angle 30 degree from the magnetic field, if this is magnetic field and this is current, this is magnetic field, this is current. Current is expected along x axis. If magnetic field is in y axis, current is expected along x axis. Okay, but current is at 30 degree from y axis. What would be the force? Okay, then then whatever the current's essence, if someone is standing on x axis, how much current he is feeling? If current is flowing, so from y axis it is 30 degree, so from x axis it is 60 degree. If current is flowing at 60 degree from x axis, then how much someone should feel the current essence when he is standing at x axis? Whatever current is flowing cos 60 degree. Or if I am calculating from magnetic field, then whatever current is flowing sine 30 degree. That is in x. That much current is only that will come in calculation. Now you go for cross product or this product, that doesn't matter. If current is flowing in a direction and magnetic field is flowing in a direction, then current is expected to be perpendicular to the magnet. If it is not there, whatever the essence of the current, if someone is standing at the particular perpendicular direction, how much that he is feeling the current? If wind is blowing in a particular direction and it is expected on x-axis, if someone stands on x-axis, how much wind he is feeling on x-axis? If current is flowing at 30 degree from y-axis, then 60 degree from the x-axis. If current is flowing from 60 degree from the x-axis, then if someone is standing on the x-axis, how much current he is feeling along the x-axis? So whatever current is cos 60 degree. So how much is the force generated? If force generated, if current is flowing in the x-axis, that is I, and it has length L, Li into B is the force that someone it will generate. If current is flowing at 60 degree from the x-axis, then I cos 60 degree. That much is the energy someone is feeling at x-axis. That's it. If I is at x-axis, then full cos 0 is 1. But if I current the line of the wire length line, if I am moving from x-axis angle, then current's feeling or someone is feeling the current along the x-axis is decreasing. So if current is flowing on x-axis, the magnetic field is on y-axis, then full force someone is seeing along z-axis. If current is direction is changing and it is going towards magnetic field along y-axis, what is the current's feeling? How much current someone is feeling on x-axis? That is decreasing angle by angle. That much only force it will generate. So signs of feeling something in 3D, how much it is, then how much the essence is, if someone, how much essence someone is getting. Okay, so I have kind of a working model, and there is a motor, and it rotates with 1.5 degree voltage only. So like if I, there is a motor, and motor has the same as coil, and now motor, so it is made like, if this is magnetic field, and so this is magnetic field and this is current on a wire, then it will feel the force in z direction and coil would rotate. So there is a commutator in between which will change the direction of current, so that in one direction current force will always be in one direction. So there are some mathematics inside the motor, and force is always generated in one direction. So motor will always move in one direction. So I have made a clip so that we can be able to see. I believe it should not rotate very fast. Okay. Okay, so I believe I have to touch the wire, so make it rotate. Oh, it rotates. Okay, so if I touch, I believe it is rotating. Okay, so can we see the power of vector? Okay, it is 1.5 volt battery. That's it. Okay, so it is 1.5 volt battery, and then there is a motor. So inside the motor, we have a stator. Stator is a magnet all around, and inside that coil is there, and it is made sure that every point the direction of the magnetic field and current direction should be perpendicular to each other, so that the maximum the force that is so we call it cross product in mathematics, dot product, cross product. So cross product in the sense that two vectors should be perpendicular to each other to have the maximum generated output. If they are not, then their sine theta, the angle between them, that will be taken. So if magnetic field is there and current is there, then sine theta. So if it is theta is angle is 90 degree, then sine 90 is the maximum. So then it would rotate maximum the way it rotated. So this is how it is. So concept what we are trying to show is that I think it is gone. So this is how it was. So concept what we try to show is that when we go for vectors, then please consider the direction and what is the kind of essence that we get. Okay, so it is not happy now with me, looks like. Okay, so this is the concept and dot product, cross product, but understand the science of how much energy you feel along all the component, and then you are done.